So the next skill we're going to work on is 7.3, which is proving trigonometric identities. I think of this as simplifying with a purpose. So I've been kind of saying it all the way along. Simplifying is hard because you never know where to stop. And so this is where you're going to learn if you're at your stopping point. So what we're going to be doing is verifying that a trigonometric equation is an identity, meaning that the left side is equivalent to the right side. When you're doing this, you can work with one side only, you can work on both sides, but you're never going to cross the equal sign. And you're going to try to turn the left side and the right side into the same thing. The hint is you're going to start with the more complex side first. Sometimes one side is so simple that you can't even touch it. So there's no real set way to prove a trig identity, but in my years of teaching, I've come across some common tricks that should help you. These are going to be similar to stuff that you did in 7.1 and even 7.2, but some of them might feel a little bit different. So first trick is turning everything into sines and cosines. So if you look at this first identity, you'll notice that on the left you have a sine 2x. So technically that's not considered a sine or cosine because it's a sine 2x, and we want to turn everything into sine x's. So if you look at this, you should recognize the double angle identity and realize that we could change sine 2x into 2 sine x cos x. So now that I've changed everything into just sines and cosines on the left-hand side, I'm not really going to touch it anymore. But my goal for the right-hand side is going to be turn it into 2 sine x cos x. So if I was to work on the right-hand side now, I would change cotan x into cos x over sine x, and then I would keep sine squared x the same. And then I would simplify. So I've got a sine x in the denominator and a sine x squared x in the numerator. So this would simplify to just a sine x. And then if I multiplied, I would be left with 2 cos x sine x, which could be written as 2 sine x cos x. So on this identity, I chose to work with the left and the right because I like to use these, I call them kind of glaring identities, and expand them through. But if you were a purist, you could have said, ooh, the right side's more complicated. I'm going to make that 2 sine x cos x, and then I can recognize that that's sine 2x. And then I wouldn't have had to do this step. I could have just said, oh, look, left side is equal to right side. So it's kind of up to you wherever you want or however you want to work these, but the goal is just to turn the left side and the right side into the same thing. All right, so I'd like you to pause the video and try this one. This one should feel a lot like one that we did in 7.1 with a bit of an addition of the sine 2x. Okay, so hopefully you pause the video. So you'll notice on the right-hand side, it's a 2. I can't do anything with that. So I'm going to leave it as a 2, and I'm going to work with the left-hand side. I'm going to change sine 2x into 2 sine x cos x. And then I'm going to change tan x into sine x over cos x. And I'm going to change cotan x into cos x over sine x. Okay, now I'm going to distribute. I've got 2 sine x cos x getting multiplied by sine x over cos x. And I've got 2 sine x cos x getting multiplied by cos x over sine x. And now I'm going to simplify. So I'm going to recognize that I've got a cos x on the numerator and in the denominator, so that will divide to give you 1. And I've got sine x divided by sine x, which will simplify to give you 1. Okay, so now I'm going to multiply through. I've got 2 sine x times sine x, which will be 2 sine squared x. And then I've got 2 cos x times cos x, which will be 2 cos squared x. Now, some might argue that this is pretty simple, but now we have a goal. We know that we're trying to turn it into 2. So what I recognize is that both of these terms have a 2 in common. So I'm going to greatest common factor out the 2 to be left with sine squared x plus cos squared x. Then I have to recognize that glaring identity. I think there's actually even a trick later that says, look for the glaring identities. But we've already, you can't, all these tricks, like it's hard to say this one comes and then this one comes and then this one comes because you kind of need to know them all. But what we recognize is that sine squared x plus cos squared x is 1. And then I'm left with 2 times 1, which is 2. So I've proved that left side is equal to right side. Sometimes it's nice at the bottom of all your identities to be like this. I used to mark trig identities on the provincial exams when grade 12 had one, and there was some teacher who taught their students to write QED, and it was some sort of Latin term meaning thus it is done. But yeah, find your own way of being like, I did it, you know, a big celebration sign or a big smiley face, or, you know, especially the big hard ones. It's nice to just like get that like, yes, I did it. Okay. So the next trick is looking for glaring identities. So like I said, it was kind of hard to like, you know, do one and then the other. So these two do kind of go together. So here we go again. Glaring identities, look, sine 2x. So on the left-hand side, I've got a sine 2x, which is glaring because it's a 2x and not just an x. So I'm going to replace it with 2 sine x cos x. In my denominator, I have a 2 sine x. So I can see why they did that, because now the 2's will simplify to 1, the sines will simplify to 1, and I would just be left with cos x. So now I'm done with my left because that's as simple as I can make it. I'm going to work on my right. This is your Pythagorean glaring identity. So remember, sine squared x plus cos squared x equals 1. So if I rearrange that, 1 minus sine squared x is equal to cos squared x. And even if your brain can work ahead and be like, oh, I can see that I'm going to replace that with cos squared x and it's going to simplify to cos x. No. Write it down. So trig identities are all about proving what you do in each step. So don't do too many steps in one. Make sure, like, if you're going to change this to cos squared x, show that you did it before you simplify to cos x. Every little part of your trig identity that's like an important step will have a mark put with it. So make sure you're showing all of your work. Okay, so this next one is 2 tan x over cos squared x plus sine squared x plus tan squared x equals sine 2x. So I'd love for you to pause the video and give this one a go. All right, so hopefully you gave this one a try. This one could be a little bit more complicated depending on how you do it. I always say start with the more complicated side first, but I also sometimes just like to do the easy. So I look at sine 2x and I'm like, okay, that's 2 sine x cos x. So that becomes my goal. I'm going to try to somehow turn this left-hand side into that. So the first thing I see is the glaring identity. So I guess glaring identities in this section mainly mean the Pythagorean identities. So I look at that and I'm going to replace cos squared x plus sine squared x with a 1. So I'll have 2 tan x over 1 plus tan squared x. Now, maybe at this point, you change everything to sines and cosines, or maybe you look to see if there's another glaring identity. So the other thing that I should say at some point is that nobody's trig identity will look the same. I've had people do a trig identity in 5 pages that someone else did in 3 lines, right? But as long as you don't do anything wrong, your work is valid, right? So even if you go in circles and around and around and around, as long as you don't break any math rules, it's totally fine. Okay, so if I look at this one, I would right away go, ooh, I want to look at my identity sheet. So whenever I see a 1 and a squared identity, I'm thinking Pythagorean identity. And there it is. I've got 1 plus tan squared x. I could replace with secant squared x. So I'm going to do that. I've got 2 tan x over secant squared x, because anytime I can turn 2 terms into 1 term, it's going to make my life easier. Now at this point, you know, you could do secant squared x and you could write it on top as cos squared x. Maybe you don't see that. Maybe you're just like, okay, I'm going to change the tan x into sine x over cos x, and I'm going to change the secant squared x into 1 over cos squared x. Right? There's so many ways of doing these. If I do it this way, I'd probably write it as 2 sine x over cos x divided by, I'm showing all my steps. If you went straight away to flipping that one, that's fine, but I'm trying to be careful. So we've got 2 sine x over cos x. When I'm dividing, I flip the second fraction and multiply. Then I see that I can simplify. I can simplify a cos x goes into cos squared x to leave a cos x, and then I go to multiply, and I'm left with 2 sine x cos x over 1, and then I've got my left side equal to my right side. Awesome. So like I said, maybe that's not the way you did it. Maybe you're like, ooh, that would be a good one next time. But maybe you, like I said, changed these into sines and cosines here, and then you cleared your compound fraction, right? No one way is wrong as long as you don't break any math rules. All right, go and practice some of these with this trick.